Hello. In this session, we are going to evaluate the different forms of reaction. Some reactions are irreversible, others are reversible, and others have attained equilibrium. And then we are going to try briefly describe the factors affecting reactions once equilibrium is attained. Welcome. To begin with, we can say that a chemical reaction may be irreversible. And when the chemical reaction is irreversible, the reactants are represented on the left-hand side of an arrow and the product on the right-hand side of the same arrow. In this case, the arrow representing the reversible reaction is 1 and pointing in only one direction. When, however, the reaction is reversible, it means it goes in two principal directions, the forward and the backward. In that respect, a reversible reaction is represented by two opposite pointing full arrows. For example, the white anhydrous copper 2 sulfate combines with 5 molecules of water to form the blue hydrated copper 2 sulfate. So the white anhydrous has formed the blue hydrated copper 2 sulfate. The reaction happens to be reversible, which means once hydrated copper 2 sulfate is formed, when left in the open or exposed to air, it will decompose gradually back into the white anhydrous copper 2 sulfate and the 5 molecules of water. And that is a reversible reaction process. Now, other reactions are said to be reactions in equilibrium. What's the meaning of the term equilibrium? Equilibrium is simply the state of balance between the rate of forward reaction and backward reaction in a reversible reaction process. The reaction equilibrium, unlike the reversible reaction, is represented by two opposite pointing half arrows. Two opposite pointing half arrows. Now that signifies one opposite pointing that the reaction is reversible, proceeds in the forward and then backward direction. Half arrow meaning that the rate of backward reaction is equal to the rate of forward reaction. In such an instance, we say that the reaction has attained the state of dynamic equilibrium. Now, the example here we have is nitrogen combining with hydrogen forming ammonia gas. The reaction has attained equilibrium. The forward reaction is exothermic, so it requires the loss of heat energy, which is equivalent to negative 92 kilojoules. The backward reaction is endothermic, which means it captures energy or heat in order to break the bonds. Now, since it is at equilibrium, it means at that point, we cannot exclusively identify which substance is in excess, because nitrogen combines with hydrogen to form ammonia, and ammonia breaks down to form hydrogen and nitrogen, and the sequence continues in a state of dynamic equilibrium. Therefore, it will be logical to conclude that a reaction which has attained a state of dynamic equilibrium has all factors rendered constant. Namely, at equilibrium, the concentration is constant, 2, the pressure is constant, 3, the temperature is constant. The catalyst has no role once equilibrium has been attained. Therefore, adding or removing it at equilibrium will not affect the state of equilibrium. What then is the behavior of a substance at equilibrium when any of the constant factors is adjusted? Let's say, for example, we increase the temperature once equilibrium is attained, then it will follow that the increase in temperature will be utilized in order to enhance the endothermic process. If, on the other hand, we are to increase the pressure, the increase in pressure will be utilized to enhance the process that leads to volume reduction. And therefore, we can conclude and say that the Le Chatelier's principle states that when a system at equilibrium encounters stress, it will always shift in order to oppose the stress induced. If the concentration of one reagent is increased once equilibrium has been attained, then the system at equilibrium will adjust or shift in order to utilize the excess of that substance which has been introduced. And that is what connotes the Le Chatelier's principle. As we have said also, if temperature is lowered, the reaction will shift in order to enhance the exothermic process. If pressure is lowered, the reaction will proceed in order to enhance the expansion process. Therefore, once equilibrium is attained, there are four main factors which change that equilibrium. One is the Le Chatelier's principle. 2 is a change in concentration. 3 is a change in temperature. And 4 is a change in pressure. Conclusively, we have said that the catalyst has no role once equilibrium is attained. Thank you. So that has been a description of what an irreversible reaction is, what a reversible reaction is, and what a reaction equilibrium is, and the factors affecting that reaction at equilibrium.